In a universe of staggering scale, billions of galaxies, each filled with countless stars, it's almost ironic that the thing we're most desperate to find is something so familiar. Something ordinary. Proof that we are not alone. Just 40 light-years away, in the constellation Aquarius, sits a tiny, dim red dwarf known as TRAPPIST-1e. It's barely larger than Jupiter, and thousands of times fainter than our Sun. And yet, orbiting this unassuming star is one of the most extraordinary planetary systems ever discovered. 7 rocky, Earth-sized worlds packed tightly together, closer to their star than Mercury is to ours. It feels almost intentional, as if nature set up a controlled experiment and asked a single question. Can life exist here? Over time, scientists began narrowing their focus. Some of these planets were ruled out quickly, too hot, too cold, or likely stripped of their atmospheres entirely. But one world refused to be dismissed. TRAPPIST-1e sits right in the middle of the star's habitable zone, receiving about 2/3 of the energy Earth gets from the Sun. Because the star is so dim, this narrow region is the only place where liquid water could exist. And if life as we know it needs anything, it's water and an atmosphere to protect it. That's where the James Webb Space Telescope changes everything. Webb can do something no telescope before it could: analyze the thin veil of gases surrounding a planet light-years away. As TRAPPIST-1e passes in front of its star, Webb measures how starlight changes as it filters through any atmosphere present. Certain molecules absorb particular infrared wavelengths, leaving behind a chemical fingerprint. The early results are surprisingly hopeful. Scientists have already ruled out a primordial hydrogen-helium atmosphere, which would have made the planet hostile to life. They've also ruled out a thick, Venus-like carbon dioxide blanket. Instead, the data hints at a heavier, secondary atmosphere, one that could potentially redistribute heat across the planet. Even though TRAPPIST-1e is likely tidally locked, with one side in eternal daylight and the other in endless night. That doesn't mean this world is Earth too. TRAPPIST-1e may be a colder planet, where liquid water exists only on the star-facing side or along a narrow twilight band between day and night, a region known as the Terminator Zone. Methane could dominate the atmosphere, creating a reverse greenhouse effect that actually cools the surface, or the water may not be on the surface at all. TRAPPIST-1e could hide a subsurface ocean beneath an icy crust, warmed by volcanic activity, much like Europa or Enceladus in our own solar system. But there's a catch. Red dwarf stars are violent. TRAPPIST-1 unleashes powerful stellar flares far more frequently than our Sun, capable of stripping atmospheres over billions of years. Paradoxically, those same flares may also be essential for life's chemistry to begin, providing the energy needed to form complex molecules. And now, as TRAPPIST-1 enters a calmer phase of its life, there's a chance that TRAPPIST-1e could retain or rebuild a stable atmosphere, especially if it possesses a magnetic field driven by tidal heating deep within its interior. So, TRAPPIST-1e remains suspended between two possibilities. It could be a cold, barren rock, or one of the closest places in the cosmos where life might exist beyond Earth. With more observations planned using the James Webb Space Telescope, scientists hope to confirm whether this planet truly has a stable atmosphere. And if it does, the search for life may no longer be about where, only when.